So here we are for part 3 of section 5.1, and our job is to evaluate the following. So what we're basically trying to do here is take all of this business, the rules of integration, of indefinite integration, and just apply them. All right, so first things first, the integral of 3x dx. So I have my operator here that tells me to take an antiderivative. The dx, the differential dx, tells me an independent variable is x. My integrand is the expression 3x. So if I'm writing this thing out, if I'm doing step by step by step, I would say this. This becomes 3 times the integral of x dx. I'm treating that 3 right there as a coefficient, so I'm just moving it out in front. I'll deal with it later. And now I'm going to take the integral of x dx. Well, x is really x to the first, so what I'm going to use is I'm going to use the power rule. And so that's going to give me 3 times x to the 1 plus 1 divided by 1 plus 1, and then of course plus c because I'm performing indefinite integration. Cleaning this up a little bit, I'm going to get 3x squared divided by 2 plus c, and then there's my final answer. Oops, I should make that a bit bigger because it crossed out the exponent of a 2. There's my final answer. Okay? So indefinite integration. You'll notice that in the step from here to here, the integral symbol and the dx disappeared. And the reason that those things went away, the reason they disappeared is they're operators. When I did the operation, those symbols go away. Okay? You notice I'm not using any equal sign or linking anything like that. I'm just performing step by step for the operation. Okay? All right, so here we go again. My job is to do an indefinite integral. I've got my operator there and there that tells me that I'm doing an indefinite integral. My dx, my differential dx, tells me that the independent variable is x. 1 over x squared is my integrand. Okay? Problem is, when I went through all my rules up here, I don't have a rule up here for 1 over x. Or 1 over x squared. I got a rule for 1 over x, but not 1 over x squared. So I'm going to have to do something that we did a lot of when we took derivatives. I'm going to have to rewrite my integrand and say that this is now going to be the integral of not 1 over x squared, but x to the negative 2 dx. The operator is still there, but now I have something as my integrand that I can apply a rule to because I have a rule for x to the nth. I have a rule for the power. Okay? So the power rule says that this is going to become x to the negative 2 plus 1 divided by negative 2 plus 1, and of course plus c. You'll notice that the operator is gone because I performed the operation. The only thing left to do is to clean that up a little bit. This is going to give me an exponent of negative 1. This is going to give me a negative 1, so that gives me negative 1 over x plus c. And there's my indefinite integral, the most general indefinite integral. Right? And I'm just going to continue doing this. Hey, look at this one. Wow, this one's complicated. No, not really. There's an operator that tells me what to do, and the fact that there are 3 terms is no big deal. It just means to break the thing apart and do 3 integrals. So what this really is going to become, it's going to become 2 times the integral of x to the 4th dx minus 5 times the integral of x squared dx plus the integral of x whoa, what happened there? That was weird. Dx. Okay. And then I just take each of these, since operator, 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 power rule, power rule, power rule, I'm just going to apply the power rule. So the first term will be the 2 times x to the 4 plus 1 divided by 4 plus 1 minus 5 times x to the 2 plus 1 divided by 2 plus 1 plus x to the 1 plus 1 divided by 1 plus 1 plus c. Now I know there is at least one of you out there who was thinking, does he really expect me to write this every single time like that? Absolutely not. Your goal should be to not have to rip this thing apart and write it as 3 integrals. Your goal should be to not have to pull these coefficients out every single time. Your goal should be to not have to write this like that every single time. Your goal should be to get this to be 2 to the fifth x to the fifth minus 5/3 x cubed plus 1/2 x squared plus c. Ideally, ultimately, you want to be able to go directly from here to here in one step. Okay? That's what our goal should be. And that's where you should be putting yourself when I'm done with chapter 5, sections 1, 2, and 3. I can do that I don't need to write these intermediate steps. But we're just learning it right now. And since we're just learning it, we write all the steps. Okay? All right, how about this guy? I got a problem. I've got an operator. I'm good there. I have an integrand, but I don't remember a rule for square roots. So again, I'm going to do what I've done 1,000 times before when I did my earlier work, taking derivatives. I'm going to rewrite this as x to the 1/2 dx. Okay, now this is the first one we had with a fractional exponent. So power rule still works. So I'll still use the power rule here. Okay, so this is going to become x to the 1/2 plus 1 divided by 1/2 plus 1, and of course plus c. And now I'll clean this mess up. Right? That's going to give me x to the 1/2 plus 1 is 3/2 over 1/2 plus 1 is 3/2. The nice thing about this is once you add it here, you get the same thing there, right? And then plus c, but this is not considered good form. So then I'm going to flip and multiply, and then this will become 2/3 x to the 3/2 plus c. And this will be our most general antiderivative. What you're going to start to see is you're going to start to see relationships. Right? What's the relationship between this number and this number? Right? And it's the same relationship that's been hiding in all of them so far. Right? 2, do you see a 1/2 hiding there? 5, do you see a 1/5 hiding there? 3, do you see a 1/3 hiding there? 2, do you see a 1/2 there? So whatever that new exponent is, the coefficient is the reciprocal of that. Okay? How about this guy? Well, if I'm writing all the steps out, there's my operator. The differential dx tells me my variable is x. There's my integrand. That 2 is a coefficient, so I could write this as 2 times the integral of the sine of x dx. Now, there's no math that I do to get the antiderivative. Just memorize it. The antiderivative of sine is negative cosine, so that's going to give me 2 times negative cosine x plus c. Now, I want to make a point to talk about something here. These parentheses right here, while not necessary, should be there because I have seen way too many times people make the incorrect next step and not get this as their final answer because they neglected those parentheses and somehow incorrectly this just turned into 2 minus cosine x plus c. And that is not correct, and that is not good, and that does not make anyone happy because that's a mistake that shouldn't be made. The 2 is a coefficient. It's multiplied. Okay, so just be careful with those little things. Sometimes we get so focused on the big picture that we lose track of the small picture. We get so focused on the antiderivative that we forget that the coefficient is multiplied. Okay? Now, you want to see one, the last one I put on here for this page is one that is surprisingly often missed, but yet at the same time is simple. It's so simple that it gets missed. Right? Indefinite integral, there's my operator. There's my integrand. What is the antiderivative of 1? Well, the antiderivative of 1 is x plus c. And there's my most general antiderivative. Right? I don't know why this one causes people so many issues, but it does. All right. We're at 10 minutes. This one should take a good few minutes. All right, let's take a look at this one. Now, this is a different example because the directions are different. It reads, find all functions g of x such that their derivative g prime would be 4 times sine x plus the fraction 2x to the 5th minus the square root of x over x. Okay? So essentially what we're saying here is, and we're going back to that definition of the integral of g prime of x dx is going to be equal to gx plus c, and that will be all functions. So this is what we need to do. We need to do an indefinite integral. We need to find the antiderivative of 4 sine x plus 2x to the 5th minus the square root of x divided by x. That entire thing is my integrand, and because that entire thing is my integrand, I wrap that whole thing up in that set of parentheses. Right? The integral symbol and the dx are my operators. Now, I know that I can rip this thing apart at that addition symbol, so I'm not worried about the two terms, but I am worried about this second term because that thing's a hot mess. But I remember something from taking derivatives. Every time my job was to take the derivative, and the denominator was a monomial, I knew that I could rip the fraction apart and simplify it. So that's what I'm going to do here. I'm going to say this is going to become the integral of 4 sine x plus 2x to the 5th over x minus x to the 1/2 over x dx. And now I'm going to further simplify these two. And so I'm going to get the integral of 4 sine x plus 2x to the 4th minus x to the negative 1/2 dx. So I simplified those two expressions. Now I'm going to go ahead and start taking antiderivatives. Now I just did one that looked like this right up here. 2 sine x became negative 2 cosine x. So what do you think 4 sine x is going to become? Negative 4 cosine x. Right? How about 2x to the 4th? Well, didn't I do 2x to the 4th earlier? It was right here. And what did it become? Well, it became 2/5 x to the 5th. So once I've done an antiderivative, if I remember what it was, I can just write it down because I remember it. Now, I have not yet done x to the negative 1/2, so I'm going to have to figure this one out. So according to the power rule, that's going to become minus x to the negative 1/2 plus 1 divided by negative 1/2 plus 1, and of course, big old plus c on the end. So then cleaning this thing up a little bit, I'm going to get negative 4 cosine x plus 2/5 x to the 5th minus x to the 1/2 divided by 1/2 plus c, but divided by a half, flip and multiply 2. So I'm going to get negative 4 cosine x plus 2/5 x to the 5th minus 2 root x plus c. Okay? Now, if I wrote that down as my final answer, I would be almost right. Because up here, when they asked me just to find antiderivatives, then the final answer was just an expression with a plus c, 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 But here, what did they ask me to find? They gave this thing a name. They said its name is g. So I need to name this thing and say then that g of x is negative 4 cosine x plus 2/5 x to the 5th minus 2 root x plus c, and give it its proper name because that's what the problem asked for. All right, I'm going to end this video here. We'll come back and do part 4. Is that going to be? Of section 5.1, we'll take a look at initial conditions and particular solutions. So I'll see you all back here for part 4.